Welcome back, and we are going to finally get into some nice old word problems or application problems. Okay, so again, pause the video if you need to read over these contexts. I'm going to jump right in. Okay, so here we go. The context here is we're talking about a speeding ticket and then the price of a speeding ticket. Okay, so it says for part A, write a linear function to model the cost of a speeding ticket based on the miles per hour over the speed limit. Okay, so the first thing I find helpful in these contexts is to identify, at least in, so if I'm working in part A, I want to think about what y is equal to, like what y represents in the context and what x equals. And that is actually telling me what y and x is in this first exercise. So it says, write a linear function to model the cost of the speeding ticket based on the miles per hour over the speed limit. So this is actually saying this is y and this is x, because we would say write this as a function of, so this is that this based on part means function of whatever follows. So we want to determine y based on this. So this is our dependent and this is our independent variable. So y is going to be the price of the speeding ticket. Okay, so make sure if variables are not defined in the context, you do need to define them. Okay, so, and then this would be the miles per hour over speed limit. Okay, so then here, what I know is that, okay, to determine y, they say in the example, by first charging 125, so the cost is 125 off the bat. That's expensive. And then they add, so they add $15 for every mile per hour over the speed limit. Now, I'm noticing some language here. Mile per hour over the speed limit, mile per hour over the speed limit. So, oh, that's just x. Okay, so there we go. And then it says write a linear function. So instead of y, I'm just going to write f of x. And I'm done. That's all you have to do for part A. Translate the words into mathematics. Okay? All right. Part B. It says evaluate your function for 10 miles of the speed limit and interpret the meaning in the context. Okay, so we have f of 10, right? Because it says 10 miles per hour over, or 10 miles, oh, I forgot the per hour. You get the idea. Okay. 125 plus 15 times 10, and so then this would be 125 plus 150, or 275. Okay, so then in context, again, this is a y value, right? So this is a y value, so that we would say the cost will be $275 if traveling 10 miles per hour over the speed limit. Kind of spendy. Okay. Okay, part C. What's the value of the vertical intercept? Okay, then now vertical intercept, that's our y-intercept. Okay, so I know that to find the y-intercept, I have to let x equals 0. Okay, so then really I'm just saying find f of 0, and so when I do that, that's 125 plus 15 times 0 is equal to 125. Okay, so now answer that first part. What meaning, if any, does it have in this context? Well, we could really kind of follow the template that we set up over here. The cost will be 125 if traveling 0 miles over the speed limit. But wait, you're traveling exactly the speed limit. Would you get a ticket? No. So actually here we would say there's no meaning here. No meaning, as you would not be given a speeding ticket. Now this one, the reason I included this one is because I want you to be able to say, okay, yes, this is the mathematics, but then you always have to translate, at least in a context, the mathematics back to the scenario. Okay, does it make sense? Does it not? You can do all the mathematics and it could be fine, but sometimes it just doesn't make sense. Okay. Next example, you see there's A, B, C, and D. Pause the video and read it if you need to. I'm not going to do part D. I'm going to have you do that on your own. So for part A, okay, if it says a linear function for the conversion such that Fahrenheit, okay, so I'm just going to write this, so temperature in Fahrenheit, I'm going to call that F, I'm not going to define it out right now, is a function of the temperature in Celsius. Okay, so that is to say our Y is like F and our X is Celsius. Okay, so using the information given above, I would recognize that the information we're given says that 0 Celsius is the same as 32 Fahrenheit, so I'm making ordered pairs. And then the next thing would say that 100 Celsius is the same as 212 Fahrenheit, so X and Y respectively. Okay, so then using these, I can get the slope. So I get 212 minus 32 over 100 minus 0. And if I simplify this, so this is 180 over 100. And I know a lot of you are going to reach for a calculator and give me a decimal. And I roll my eyes at you because the fraction 9/5 is a lot easier to work with. Okay, but now I have the slope, I have a point. Let's use point slope form. So I get F is equal to, or sorry, F minus, let's try that again, F minus 32 is equal to 9/5 of C minus 0. And so then, let's see, yep. And so then here we get F is equal to 9/5 C plus 32. And the only reason I did that is because technically I would have to write this as a, so it says write it as a function, so it'd be F of C is equal to 9/5 C plus 32. Okay, there we go. Now in part B, you're going to read it and say, okay, well, how's that different than part A? Notice that the language function of is the same, but then Celsius and Fahrenheit change roles. So that is to say, in part B, now our Y is Celsius and our X is Fahrenheit. Okay, so then my coordinates sort of reverse, so it's 32, 0, and then 212, 100. So then I'm going to let you compute the slope, but at the end of the day, again, in fraction form, you get 9/5. So then you get C minus 0 is equal to 5/9 F minus 32, or rather C is equal to 5/9 F minus 32. And so then we can get the function F of F, a little awkward, but we can work with it, is equal to 5/9 F minus 32. Okay, and so that's that one. For part C, it says using your answers to part A and B, what temperature is the same for Celsius and Fahrenheit? Well, so for part C, so what we're saying is that Fahrenheit and Celsius have to be equal. Well, okay, then you're like, oh, I just need to set equations equal to each other, and that could be a little problematic. But what I'll say is that it's going to be equal to X. Okay, so take one of the two equations that you found, so either this one or that one, and replace F and C with this other variable X, and see what you get. So you get something like X is equal to 9/5, using part A at least, X plus 32. Okay, now this is as simple as solving for X. Move the 9/5 over, so you get negative 4/5. X is equal to 32, and then you would divide by negative 4/5, and you get negative 40. Okay, so we would say the temperature negative 40 degrees Celsius and negative 40 degrees Fahrenheit represent the same temperature. Kind of cool. Okay, there is another question. I want you to try and write the domain and range for both A and B. Okay, and then just notice what happens with our domain and range. Kind of an interesting little thing that we'll see later on in chapter 1. All right, that's going to wrap up this video.